So this is the distribution on weight of children. Children are classified based on their weights. They have picked the closest weight to group the children. Let me give some frequencies. Okay. So clearly these are our variable values x. A variable is a quantitative characteristic numerically measured which changes from place to place and person to person. So here children have the variable characteristic as height, and based on those values they are grouped into various classes or the discrete cases 20, 25, and so on. So when we have x and f given to us, the arithmetic mean is given by the formula total of fx divided by total of f. So you have to obtain the product of f and x and divide it by the total of f, divide the total of fx by total of f. So we have x values, f values here. So multiply each pair and write that product and then obtain the total of that. Okay. So we'll have 6 into 20 is 120, then 200, 360, 185, 75, and 120. Then obtain the totals. This is 34, 120 plus 200 plus 360, 175, and 120, which comes to 975. So arithmetic mean is 975 by 34, which comes to 28.6765 kgs. And then you can define your mode. Mode is the x value with largest or the highest f. And the largest f in the data is 12. So we indicate the largest f as fm, frequency of mode, and for mode of the. So 30 is the value. Don't write the frequency. The measures are defined for the variable. And whenever we have frequency data and we wish to obtain the value of median, the first step is computing the less than cumulative frequencies. That is, add the frequencies from the top and write it from the top. So first value remains the same. Then it is 6 plus 8, 14, 14 plus 12, 26, 26 plus 5, 31, 31 plus 3, 34. Now median is defined as value of x whose LCF is just greater than n by 2. LCF is just greater than n by 2. Now, in the book, they might be using n plus 1 by 2, and in that case, they will say just greater than or equal to n plus 1 by 2. So, either way, you can obtain the value of median. We stick to n by 2 because you are in the next case, that is for the continuous case, we'll be using that n by 2 only. N is the total frequency here. Capital N always indicates the total frequency. N is 34, n by 2 is 17. Our LCF just greater than 17 is 26. So LCF just greater than 17 is 36, and 36 or 26, 26 as the value of x as 30. Therefore, we say m is also equal to 30. So this is how we obtain these three measures for the discrete data. So first step, finding the LCF. Second step, computing the value of n by 2. Third step, observing the LCF or picking the LCF which is just or immediately greater to 70. There will be many values which are greater than n by 2, of which pick the one which is least and then obtain the respective value of x. That gives you the median. For mode, just identify the highest frequency, pick the value of x. So if in case there are two highest frequencies, at this point of time, you could say there are two modes. But when you are in a situation where you have to use that particular value of mode in obtaining some other measure based on mode, then you will use the formula z is equal to 3 median minus 2 mean to pick up or come up with a single value for our mode. it down quickly. ಆಯ್ತಾ? Next type of distribution, we could have a continuous distribution, continuous frequency, also called as grouped frequency distribution. So I'll have the classification based on various sub-ranges called as groups or class intervals. So let me take height, maybe in centimeters, and number of soldiers. Now, even in this case, the formula to find mean remains the same. X bar is equal to sigma fx divided by sigma f. What we mean by x here is the midpoints of every class interval. So this method of computing mean for a group distribution is based on the assumption that every value in that group is closer to the midpoint. Every value is closer to the midpoint. So it need not be so, but it works out well for most of the cases because we are not just leading on that particular value, but we are depending on the fx, which is somewhat the total. And total, if even if your x values are not closer to this x, the total will be closer to fx. So that's why we'll be using this formula. So what I mean is there are 13 observations in this group. We say all these 13 observations are same as 155. So that need not be true because if I'm just using 155 instead of 150 to 60, I'll be wrong. But what I'm doing is to obtain the mean, I need the total of all those 13 values. So sum of 13. So these 13 values will be from 151, 150 point something up to 159. So if you look into the total of those 13 observations, that will be closer to 13 into 155. So the formula works out very well for almost all the cases. So you can use this. But these techniques, as said, they are developed in the stages of human life where uh, much of the advanced calculators or computers were not there. So we use the group technique like this. But since nowadays we have many softwares available, so instead of grouping and obtaining the mean for a group frequency distribution, you could use the raw data itself to generate the mean, and that mean will be accurate compared to this cases. So this is, we'll use the frequency distribution just to present the data for the calculations of any measures like measures of central tendency or measures of dispersion. You'll be using the raw data only. You can use your Excel or any other software in obtaining the measure. So first step will compute the midpoints here. So midpoints are indicated by x and given by the formula upper limit plus lower limit divided by 2. The sum of these two values or the average of these two values gives you this. So 165 to 170, 167.5, 172.5, 177.5, and last interval is 180 to 190. So midpoint is 185. Now compute fx, obtain the total of fx, total of f, write the ratio that gives you the value of mean. Compute ಮಾಡಿ ಹೇಳಿ ಎಷ್ಟು ಬಂತ ಆನ್ಸರ್? ಬಂತ ಆನ್ಸರ್ ಬಂತ?
Yes, sir.
How much is that? It's going to 169.0726 centimeters. Verify that. Now coming to the method of finding median, this is class interval data, so it is given by a formula, interpolation, or an approximate formula, which gives you the value of median, and that is given by L plus n by 2 minus CF divided by F into C. So first step is identifying the class interval where the median lies, and that is the class interval with LCF just greater than n by 2. So you need the values of LCF to proceed. On the next column, you can write LCF. We'll have 13, 34, 64, 99, 119, and 154. Study the lot. Total frequency is 124, right?
Yes, sir.
So n by 2 is nothing but 124 by 2, which comes to 62. So I have to pick the LCF greater than 60. So LCF greater than n by 2 equals 62 is 64, and identify that particular class interval. So this is how you identify the class interval where the value of median lies. So this class is called as median class. So what is median class? Median class is the class interval where median lies, or it is also the class interval with LCF just greater than n by 2. So median class is the class interval where median lies, or the interval with LCF just greater than n by 2. Now once we have the interval identified, now we can identify the values of the various terminologies used in M. So that is L. L indicates the lower limit of the median class. So in this case it is 165 plus n by 2. N by 2 is already computed. N by 2 is 62 here, 62 minus CF. CF indicates the previous LCF. Whatever the class you have identified, take the previous LCF value and F indicates the frequency of the median class, which is 30 in this case, and C indicates the class width. 165 to 170, the class width is upper limit minus lower limit, 170 minus 165, which is 5. That is the value of C. So first you'll do the subtraction, multiplication and division, and at the end you will add. So 62 minus 34 is 28, I guess. 28 into 5 divided by 30 comes to 4.6667. So when I add 165 to that, I get 169.6667 centimeters as the value of median. Taken up. Next, we'll learn how to compute the mode. For mode, we have to obtain the modal class. That is the class interval where the value of mode lies, and that is given by the formula L plus Fm minus F1 divided by 2 Fm minus F2 minus F1, and Fm is the highest frequency. Mode, most repeated value, much the repetition or more the repetition, more high the frequency will be. So this is the modal class. Modal class is again the class interval where the value of mode lies. So once you identify the highest frequency, we'll take that as the frequency of mode. Its previous frequency will be F1. Its successive frequency will be F2. Its lower limit is L. Its difference or the class width of that interval is our C. So when you substitute that, you will get your Z is equal to L in this case 170 plus Fm is 35 minus F1 30 divided by 2 into Fm 2 into 35 70 minus F2 minus F1 into class width of this is 5. So you will have 170 plus. So first you will do the subtractions and multiply it by 5 and divide it by the denominator. 35 minus 30 is 5 into 5, 25 divided by 70 minus 50, 20. So you'll get 170 plus 25 by 20 is 1.25. Yes, 1.25. So it comes to 171.25 centimeters. So that's the value of mode or this distribution. Now the next measures for the data are measures of location or position, and they are statistically called as quantiles. 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 So quantiles are nothing but the values of x at some specific positions. There are many such cases. Could divide the distributions into so many equal parts, of which the commonly used are median, measure, which divides the distribution into two parts. Then we have quartiles, which divides the distribution into four parts. Similarly, we have deciles as well as percentiles. So what do we mean by partition values? These are the values of x at certain position, because we want to see the properties like, say, what is the particular value of x in this position. So if I want to chop out first 10% and last 10%, so which value of x has to be selected? What should be the range? So to identify the extreme values, we'll be using the concept of the measures of location, generally called as quantiles. So if you are dividing the entire distribution into just two parts, then the middle, you will cut the distribution at the midpoint, and that point or the middle value is called as median, indicated by m. So we already learned how to compute median for all the three cases of data, raw, discrete, and continuous. The same procedure will be extended for the other three cases also. Now the next measure is quartiles. We are interested in those values of x, which divides the distribution into four parts. So imagine that you are dividing a straight line or a stick like this into four parts, equal parts we are talking here. So we'll first cut the stick or the straight line into two parts by dividing or breaking it at the central point, and then each of the obtained parts will be further broken down at those middle points. So only three cuts are sufficient to produce four equal parts of a stick. Similarly, if you're talking about a frequency distribution, so you can cut it at three parts to obtain the equal number of observations. So here, don't look into the areas. We are talking about the number of observations falling into those four groups, and the cuts which are the positions of x where the cuts are made, those are called as quartiles, indicated by q1, q2, q3. Q1 is called as lower quartile or first quartile. Q2 is middle quartile. So if you look into this middle quartile, again it is the midpoint of the distribution. So we say Q2 is same as median, and Q3 is called as the third quartile or the upper quartile. Now, if you talk in terms of the area, you will have 25% of observations for towards the left of Q1, 75% observation on the right. Why? Because your Q1 is such that it is producing, the quartiles are producing equal parts in the distribution. So they are somewhat dividing the ratio, or each part is 25% in compared to the distributions. So 25 towards the right, 3 times of 25 towards the right, and 25 towards the left. So if you look into the area or the frequency polygon, the area under the frequency curve, that is also equal to 25%. And similarly, Q2 is the value which divides the distribution in the ratio 2:2, which is same as 1:1 or into two parts. Q3 is the distribution which divides the Q3 is the value which divides the distribution in the ratio 3:1, that is 75 parts towards the left, 25 parts towards the right. So this definition only gives us the formulas in identifying the position. So in case of median, I said I need the middlemost value. So we said divide the entire number of observations into two groups and take the position as n by 2 or n plus 1 by 2 in the raw data, because we are producing only two equal parts in the distribution. Now we are producing four equal parts in the distribution. So somewhat the formula will be now similar to n plus 1 by 4 and n by 4. But there are three different values. Each are producing the ratios into four parts, and there are particular ratios also, 1 is to 3, 1 is to 1, as well as 3 is to 1. So when it comes to Q1, I'm dividing the distribution into four parts, but I'm considering only the first 25%. So you have to somewhat, talk about either in terms of the left area or in terms of the right area. So we'll stick to the left concept. So Q1 is the value of X, which is covering the first 25% of observation. So when I say first 25% of observation, it will be equal to n by 4. Now if I talk about the second uh, measure, which is Q2 here. So it is covering 50% of observation. So it will be same as 2 times of 25. So we call that as 2 into n by 4, or 2 times of n plus 1 by 4 value of X. Now, if you look into 2n by 4, mathematically you can simplify that as n by 2. So hence we say the second quartile is same as that of the median. So for all distributions, median and the second quartile are numerically same. Now if you look into the value or the position of Q3, it is using 3 times of 25% in the right side. So it is that value which is dividing the ratio in the position 3 is to 1. Therefore, its position will be 3n by 4, or 3 into n plus 1 by 4. So generally, this could be combined in a simple formula, and I could say Qy is equal to I into n plus 1 by fourth observation in raw data in the arranged data. So whenever we are talking about position, measures of location, you have to write the data in the increasing order. So array irಬೇಕು ಆಮೇಲೆ ಬರೀತಾರೆ. And in case of discrete frequency data, so we have this as the value of X with LCF just greater than this. So all these are position. The procedure is similar to that of our median. So what we do here, so we divide the distribution into four parts and try to pick the first 25 observations, such as discovering 25% of observation towards the left. So in this case, it is very easy. So it is the value of X with LCF just greater than IN by 4. So your I in this case will take three values, 1, 2, 3, for three quartiles. And for continuous data, you will have a larger formula similar to that of median. So you will have I into n by 4 minus CF divided by F into C. So if you want Q1, take the value of I as 1, you will get Q1 is equal to 1n by 4. For Q2, take I as 2, and for Q3, take I as 3. Notations are same, but as the position changes, In by 4, 1n by 4, 2n by 4, 3n by 4 changes, the LCF value changes, and therefore the class interval changes. Once the class interval changes, your LCF, F, and C changes, so you'll get different values. There could be cases where Q1, Q2 belongs to the same interval, but numerically the values will be different. So Q2, Q3 belongs to the same interval. That could happen. Now extend it to the same concept of dividing the distribution into four parts. Now we try to divide it into two parts. Now, as said, they are all the techniques of identifying the extreme value. So what we are doing when it comes to quartiles is that since my extreme values are either in the lower end of the distribution or in the upper end of the distribution, if I chop out the first 25% and the last 25% and only concentrate on this as the data, then this is free of the extreme values, and I could use only those values to compute the measures. But removing 25% on either side will cause you the loss of 50% of information regarding the population or the sample from what the data you have collected. So many people feel that losing this 50% information is not good. So you could do so when you have very large number of observations, like you have hundreds or thousands of observations, then chopping 50% doesn't lead to any such problems in the statistical calculations. But for less number of data, chopping 50% of the data, removing 50% of the data comes at certain cost. So we cannot use that. So what we do is we extend the same concept. So instead of dividing it into 4 parts, you could divide that into 5 equal parts. So we'll call them as quintiles. Then you can divide the distribution into 6 equal parts, 8 equal parts, and so on. And the commonly used cases are deciles and percentiles, where we'll be dividing the distribution into 10 equal parts. So to make 10 equal parts, 9 cuts are sufficient. So first you'll do a cut in the middle, and then each of this will be divided into 4 cases. So these are the 9 values, 9 positions indicated by D1, D2 up to D9. Again, D5 is the middle value, so that is same as the median. Now, if you look into every part is 10% of the original distribution. So your D1 is dividing the distribution in the ratio 1:10, and your DI in general is dividing the distribution in I:10 parts. So if I say D4 is dividing the distribution into 4:10 parts. 4 parts towards the left, the remaining 6 parts towards the 10. So 4 by 10 becomes the position of your D4. There the ratio is 4:6. Now you can extend the same formula. Di is equal to I into n plus 1 by 10. So denominator will be 10. So this is for raw data. I into n by 10 for discrete frequency data, and L plus In by 10 minus Cf divided by F into C for the continuous data. So if I'm using the concept of chopping to avoid the extreme data, so now I'll be losing 10% on the either side. So again, if you're dealing with very small number of observations, like 12 observations, 6 observations, 8 observations, so the reason is in almost the cases when it comes to the field of medicine and biology, extraction of data will be through the through performing the experiments on the live beings like animals or the laboratory rats. And if the experiments are successful, then it will be carried out on a certain number of people. So only less number of sources will be available. So you could just extract 3 values or 5 values, or at a certain point of time even 1 value also. So removing those observations becomes difficult. So 10% is also a huge number at certain cases. Therefore, we try to divide the distribution into 100 equal parts by making 99 cuts, and these 99 values of x, which divide the distribution into 1 equal part, so 1 part, 1 percentage, those are called as percentiles. So even in the percentiles, the P50 will be same as the middle value. So median is same as second quartile, same as 50th decile, is same as 50th percentile. Similarly, if you look into quartiles, your Q1 will be same as your P25, and Q3 will be same as P75. Each of your decile will be equal to the respective percentile when you increase the position as 10 times of that. And again, when you look into the formulas, your PI, ith percentile for raw data, is IN by 100, IN by 100, and L plus IN by 100 minus CF into C divided by F. So we'll see how to obtain this numerically. Median easy ಇತ್ತು, ಬರೀ divided by 2 ಮಾಡಿ ಈಸಿಯಾಗಿ obtain ಮಾಡ್ಕೋಬಹುದು. middle value identify ಮಾಡ್ಬೋದು. But identifying the 5th value, 6th value, or 5.6th value, 4.3rd value becomes difficult. So we'll see how to compute them numerically in the next class. Okay. So I'll stop here. If you have any doubt, you could ask.